All right, welcome everyone. This is the status update for SDS-P4A. My name is Gabriel Watson, and I'm new to the company, and this is also a new product. So I find that I'm in the right place, and I hope to give you a good insight on current affairs of P4A and the future as well. So first of all, just a disclaimer, some of the information we're sharing is not yet defined for the next year or so, and it's plans that we have, and maybe it will not pan out. So we just advise, against making decisions based on the statements here. Let's move on. To start with, I just wanted to give a quick overview on design suite, substation design suite, the history. It was developed by Automation Force, launched in 2013. Okay. Originally, it was a plugin for Inventor and also AutoCAD Electrical. So it had these two parts working together, and eventually was acquired by Autodesk very quickly after, licensed to SBS. And there were two products that lasted for quite a long time. Eventually, P4A was launched in December 2021. So we have been introducing new tools through P4A, and also some of the tools that P4I also had on the physical side. And the idea here is that we basically have intelligent station modeling. So intelligent modeling could be in different tools, but the purpose is the same. We're trying to provide a solution that covers the same issues the industry has. Why P4A? So here's a slide where we're trying to show the reasons why we invested into this solution, to be more flexible and also be customer driven. As the customers face the challenges, we try to be there with them. We have an estimated about 500,000 people every year, professionals being trained in AutoCAD. So it's a huge pool of users, great interoperability with civil surfaces in P4A, underground conduits and conductors, georeferencing. So there's a lot of capability in P4A that we're just opening up the ability to connect to other tools from there. More direct integration also with the PNC products, the protection and control. It was a customer requested alternative to SDS and Inventor as well. So this is something that we're, again, doing to keep up with customer needs and wants. So there's also a very big reason for SBS to invest in this, is because we are using the code base for AUD, another product for distribution, and all the testing development. And there's a lot of cross-discipline synergies from even users that are familiarized with AUD. They can move on to P4A, or they can talk to other users that are starting in P4A. So there's a lot of cross-training that can happen. At the end of the day, also for future developments, there's a simpler platform in P4A based in AutoCAD Map 3D. We have a platform that can be automated easily, can be customized, and it can be also expanded to different industries, which are seeing more attention now. So P4A has what I like to say 4 pillars here. Just to give an overview for those that are not too familiar, there's an industry model, which is a database embedded on the drawings, material catalog, which is part of the configuration and goes in your drawings, and part editor, which you add 3D models that you use those as features in your design. And you also have the rules engine, which is where you can really configure a lot of the new functionality or a lot of the standardization, like all the standards from a company can be moved into a rule, and that becomes something that the users will be able to implement without even thinking, because the tools already take care of that. So that all feeds into this sort of ribbon, and the pick menu where you're going to be picking your models and features to place them on your design. And what I like to say is just pick, place, and connect. Should be that easy to form your 3D models and substation design. Once that is done, you adjust, describe, dimension your drawings, validate, and plot. And there you go. That's how the workflow should be going, right? So those are the major features. But we're here for a status update. So I'd like to give you some of the recent improvements for the past year, or mostly the past 6 months or so, recent improvements and highlights of those. I know David also, he gave a preview of AUD and P4A status update on development, and it covered some of these points, but I'm trying to share here some of the workflows with videos, so for the users to be more aware of how these are actually applied. So there's a quick little improvement here, which is the recent and saved filter attributes. So this basically saves you time. Just go through the demo here. So when you're picking, let's say, a circuit breaker, and you have to type in description for dead tank, and you're doing that once, and you're going to place your feature in design. I'm picking something big so it can be easily visualized with an example. And if I want to pick another dead tank, I would have to type it again. So just to save a little bit of time, there's this save filter attributes, which goes into the AUD config menu. Scroll down there, you see you can turn it to true. And once you turn it to true, it'll save the last used filter. And the recent number that I altered there will save all the last used features or models that you picked. So right now, the attribute right away has a description already picked from before, already saved. But once I pick and place a new feature on the design, I go back, I see the recently used. And if you want to wipe out the list, you can always click on the X button that is on the top right of that most recent. So quick and easy, just functionality to save time. Now, there's another functionality David covered before. I'm going to give a quick example here. When you have, let's say, stacked connectors to bypass, or situations where via design sync, you're trying to match whatever you're designing PNC, and you're trying to keep that in your physical representation. Maybe you need to bypass some of the logical connection there, and you need a different logical connection to the physical one. So I'm going to give this quick demo. So I have a sample that we use for training here. And what I'm doing is I'm going to be placing that conduit there, and I'm connecting to the other dead tank. But at the end of the day, it's just an example to show the cable is going to be created. So the logical and physical connections are created all at once. And if I select, I can see on the dashboard on the connected tab, I can see the connections there between the two dead tanks. And the physical connection or graphical is obvious there, but I can click on the button to remove the physical graphical connection and link it to something else. But that does not remove the logical connection between the two dead tanks. As you can see, they're still connected to each other. So this is just a sort of a workaround if you need to bypass. There are many connectors stacked, or in some situations we found the clients needed to do that. There's a demo here on below grade conduit. So by the way, I'm just gonna roll back 1 second here. Any questions so far? All set. This other demo is about 4 minutes, so let's I'll try to describe here. So for below grade conduit, there is a new workflow. first step along the lines is we're setting up the trench first. So we do not want to place the conduit right away. I'm placing the number of rows and columns. I have to place the maximum number of rows right off the bat, number of rows and columns, the maximum that you will be used for the network. And I set some information there as well about the depth and width and the band radius. I go through the cables, select the cable that I would like to have, and I have to cancel to go back and draw trench. So that's the step one. You're basically drawing a trench with segments, and they don't have conduit yet. We're just setting up a network. And now to create a branch, I need to branch at that location. I'm going to use a 2D OSNAP endpoint and AUD 3D ports. So that creates a logical branch there, which is a intermediate point structure to connect line features. So you have to have a point feature in between. And I'm just going to pause quickly here. This is going a little too fast. Okay. So the whole reason for setting up the network is now that you have everything laid out, you could have modified it if needed. Now you're moving on to placing your end connectors or your endpoints for those trenches. So here you could have other features already placed, but for this example, we're just using a workaround, placing the endpoints, out of the pick menu here, the model selector. So I'm going to start in this example. As you can see, I have 2 rows and 3 columns. I'm picking in total 6 cables to run. So I'm going to be selecting here a model that has 6 ports to connect to. I'm looking for a specific one I know is over there I can use with 6 ports. Takes a couple of seconds to load, and then with the AUD port snap, you can snap it to the endpoint, and it's just a matter of orienting it correctly. In this case, the ports are facing inwards to the line of the segment. For the other ends, each other end will have 3 cables, 3 conduits. So for the other ends, I will have to place a different feature that has 3 ports only. I'm not too worried about the orientation right now. Like I said, the orientation would probably be given by another feature above the ground, so you could connect to a real feature. In this case, I'm just showing how the second step goes. You place those endpoints and you move on. Now, I wanted to insert details as a step 3, and you'll see the sort of a cross section of those trenches before they're filled, which means they're going to be shown as empty, and they're quite big there, so it's easy to see they're empty. And then we're going to fill those trenches with the conduit, and you're going to be seeing how the details will fill up. Now that's step 4. We're moving on to this here. I'm going to pause quickly. So again, this option here is very important, where you can pick, to draw your trench purely. And now we're finally adding the conduit to the trench. And I'm using a special feature, which is sets of 3, because in this case, very simple example, I have 6 total conduits, but 3 for each branch. So I'm going to fill up each path with 3 cables. And I'm going to do one path at a time. So I have to select one path fully from start to end. It's drawing the cable and all the way to the ports, and the second one there. So after that point, in this demo, I would like to show like an optional thing that, in my view, if you wanted to check AUD options, it's available for everyone to change the description of that trench into something more visual. So you can change the display to lofted with line. So in that case, you have a better idea of the dimension of the trench and where it actually fills up. And there's one final step after you change the AUD options. You just have to do a AUD regen. So AUD regen basically to refresh your models and load that up. So that's a quick visualization. Gives you a good idea of spacing there. So that's not the best example, but it's a very simple idea of how the steps are involved to get to that point. Moving on to the next. I also wanted to show, this is from the previous example, I wanted to show that this is another option that is new. You can display sweeps as 3D arc solids. Right now, this is how they come. They come displayed like in multiple segments like that. And this is how they become after you change that option. So all it takes is for you to change AUD options again. You go to structural layout, generate 3D sweeps, and now the elbows are one solid sweep. And that basically is clearer for 2D plotting, so you don't have multiple, little sections as those ribs you see there on the top. Sorry. Any questions so far? Good. Custom AUD options. So in this case here, there are many options, many configurations you can do with AUD copy options now. I just wanted to give you like 4 examples here. So the first one is the default true or false. You can set up in red as showing if you do have a way to copy your models or features that you want to be using as default whenever you use it, you can set it to true and it will respect that choice. To export would be for saving. Here on the right side, you can see if its export is true, you can save it as JSON or JSON format, load it up in other applications, and many uses for that. And paste immediate is a feature I like a lot. Is basically you can use AUD copy without having to go to AUD paste. Immediately it'll launch the functionality to paste it. No containment in this case here I have on the left side. It could be no containment or yes for containment, false or true. You can include contained or you can include containers. So in that case, when you have the multiple features that are contained within each other, you're going to carry all of them. Or maybe you're trying to copy something that you don't want any other contained item within. So this is how it looks like in the bottom, the AUD copy function. The more options you load there, you can quickly add those as you see on the left side. You just click to add copy options and you can customize your options there. But they'll fill up your AUD copy options on the bottom as you see the command. Automatic port name via INEX. That's an example, mostly on the right side. I wanted to call your attention for the right side. If you are using models that are coming from Inventor, and they obviously will go through INEX to be imported to P4A. In this case, you have an option to load up assemblies where you have subcomponents with their own ports. And if you want to do it quickly and you don't really care about micromanaging the port names, you have this new functionality, sort of new. It has been there for a little bit now, but it's a way to define your ports by the assembly level, and they'll respect, as you see on the bottom right, port name format. And there are some keywords that will be respected, like the name is the sign there, and plus the number sign, which is for the number of the port. So that's basically how it works. AUD view solid. So this one is another demo I would like to show a workflow for. This is a very good tool to inspect your 3D geometry. So a lot of people might be concerned about performance. You can use it in actually any AutoCAD drawing. So if you are building individual parts or if you're building entire substations, you can select which components you're going to test with. So let's jump into the example here. We have a little bay to test with, and I'm going to run over the different options we have. This case here is solid. So I'm selecting a couple of features, and I just want to explode them. So you select basically a base point, and you explode them to see those are all the solids you selected. So you have a better notion of what's involved there. And it will give you also the how many objects were selected there. And geometry gives you more than just solids. It'll explode the entire geometry, so the line features, and the edges and vertices. And the other feature here, which is really interesting, is you can actually export a report. I'm going to pause here for a second. So you can export to CSV format your entire substation or a small item and see the exact impact of FEV. We call it faces, edges, and vertices, FEV count. But you have this whole count, which gives you an idea of what are the biggest performance killers in your design. It's a very good tool to, in your pilot projects, maybe you're trying to get your content in and you're trying to filter what are the biggest pain points for performance. You can use this tool. And lastly, there's the performance option, which is within P4A, you'll get a result that you can read from there. So in this case here, the performance is more in terms of milliseconds and how long it takes to rotate and create, let's say, orbit or zoom around your station. So it's not as much as about just the FEV count, but you also have to know that sometimes the number of faces or edges might be high. However, you have good performance, so you don't have to really do a lot. Or maybe there is something that is very low on FEV, but you still have an impact on your machine. So that this is also PC specific, like for each computer, so you can test in different users. And FPS frames per second is also a good count to be aware of. So again, this is a good tool for those that are building their library, their content. Let's move on. So this is another interesting tool. If you do have a crash and you added something into your industry model and you maybe did not save your design, or did not save your drawing, now you have a way to recover that. So let's go to the example. Now I'm opening, after the crash, I'm opening AutoCAD again. I get the drawing recovery manager as usual. But when I open that, P4A will recognize that, hey, there was a industry model database associated with that drawing. You may have lost something, and it will prompt me to recover it. You can recover or you can delete. Sometimes you don't need to recover, but just to be safe, and there you go. And it recommends to, of course, perform an AUD regen because maybe the connection to the database has to be refreshed. So go to the next one. All right, so now we're going to show a little bit of the content building workflows, how to be efficient about it. We're also not just with the products in terms of software, but we also have applications and websites and trying to provide content and training, documentation, every possible way we can to provide value to those users of P4A. In this case, utilitycontent.com is quite known for the users from P4I, for the inventor side of the substation design. But now we're trying to start to add also P4A ready parts. So what this is a website where you can browse through OEM approved 3D models. It's a library, a very, very large library of components for the industry. And you can customize some of them using configurators. So you can change the sizing, and depending on the application, you have many options to configure. So we recommend you check this out. And soon, again, we don't know how fast we're going to deliver this, but we're working hard to deliver some P4A ready parts so you can implement that into your content as you're building your P4A content. Next is the INX export for P4A. Just a little demo here, what can be done if you already have content in Inventor, or if you prefer to use Inventor for maybe simplification of models. There are a lot of tools that allow you to simplify fast also in Inventor. So there's a good synergy with Inventor. So here is a demo, I think it was Jim that recorded this one. But basically showing the functionality is you load a model, and this one came from utilitycontent.com. You can download from the website, and you're adding ports, which are the connectivity points, the snapping points for P4A. It's usually quick and easy to add the ports. You have to configure some of the iProperties, so they're all ready to go when they're exported to P4A. So that's what the demo is showing right now. You're adding some of the names and indexes for the ports, which are important, and it's all standardized also. You have to have a standard, and across different companies, most companies do similar standards for that, so we can help a lot because we have seen good practices with that. There is a document coming soon that we want to share with you where we have all the content building coming from Inventor and soon also from AutoCAD, how to use this tool. And at the end of the day, once you add your ports, you can add the clearances. So you can set up which areas of the model are live, which areas are grounded, insulated. And you can also add layers or attributes for the layers that will be applied once you import that into P4A. So you can set up all your model, almost everything you need for P4A in Inventor. And it's quick and easy. It creates an export in a format called INZ, which is a format that P4A will import through the part editor. Over here, just to show one more thing here is, yeah, so that's the document I was talking about. Coming soon, we wish to release this in the coming month or so. There is a part builder guide that displays this functionality. Yes, Tilak, you have a question? Yeah, the example, yeah, the INX example I'm just showing here is kind of illustrative, and there are more tools, and it has been made a lot more robust after this release. So the part builder guide, just to go back to this, is coming soon. It's something that will help explain how to simplify your parts once they are downloaded from the web, once you get them from OEMs. There's a lot that Inventor can help you with. So I was part of the team writing this builder guide, and I'll be happy to share because it'll be of great value. So the part editor, as I was saying, for those that haven't seen it, there is a little quick demo here. And this here is functionality within P4A where you can import the INZ file that was exported from Inventor, or through the part editor, you can also add AutoCAD-based parts. And what you do here is you associate those parts to models. So they're ready to go. They're associated to your database of models that can be applied to your substation. So again, we create parts. Parts are the 3D geometry. You add the ports to them, so the connectivity is there. The metadata, you make sure the metadata matches the model that they are going to be associated with. Once everything is ready, they can be placed on the model selectors, and from there you can place the models and create your design with them. So that's the little example. On the left side, what I'm also showing is that we have this part builder guide being developed mostly now to show how to simplify models coming from Inventor iNext tool, but also there's a lot to add on AutoCAD based part building. And that's going to be coming up in 2024. And there will be also, and I'm going to speak more at length in the next slides, about our training for next year. So we have sort of planned our learning path in a different way now. We have been training P4A in sort of a be-all end-all course that from there, a lot of clients, sometimes they take mentorship, sometimes they're already good to go. Others, they might take the video lessons we have, and they also fly with that. We've seen great results out of the box even. But we have a learning path that helps, larger teams or teams that have a better idea of their standards and where they want to arrive. This will give you more information on how to get there. And we would love to have some idea of your feedback on this as well. We want to break up the learning path into blocks that might make more sense for large utilities or maybe larger groups. So we understand that a lot of the production users are basically users that are not CAD admins. They're not going to be diving into the part building side of things. They're not going to be creating their own rules. So we want to provide a quick and easy production user course. Any junior co-op can take part of it and start producing in P4A. And then we have the part builder e-learning, which is we want to have about 10 hours or so. This is an estimation. Again, this is an idea. We have like a plan to get this content in videos so it can be easily shared in our platforms, AutoCAD based or Inventor based, leveraging iNext. And that will be paired up with a quick start course, which is the step 2B that I lined up there. So you have the basic course on the production user course. Then you go into the CAD admin course, which is the part builder e-learning plus quick start. So with those three, you already covered most of the way. And then for those that are really diving into configuration, we understand some of you have multiple clients sometimes, or maybe multiple offices. And with multiple offices or clients, you might need different configurations. So there's an administrator course or a configurator course. We haven't really coined it yet. That'll be the final step when you're ready to take that leap and configure the entirety of P4A for multiple organizations. If you are not familiar, I guess, with SBS or SDS solutions, P4A, our FAQ or FAQ is SBS Answers under spatialbiz.com. And if you have an SBS account, that's great. You can probably have access to some of the articles we have from the knowledge base. So I really recommend looking at the knowledge base because it has more content and it might answer more questions there. Soon we'll be adding that part builder guide to the knowledge base as well. So that will be all free, and that's the idea. We're trying to pave the way here for many people that are interested in this.